the last lecture we studied that let F5 be the set of all subfields of F, then intersection of all F5s is a subfield of F, and we written intersection F5 as P, and हमने ये किया था P is contained in every subfield of F, and no proper subfield of F is contained in P. Now today we define prime field. A field P is said to be a prime field if it has no proper subfield. So a field P is said to be prime field if it has no proper subfield. तो इस ये एक एग्जांपल होगी प्राइम फील्ड की, intersection of all the subfields of F because it contains no proper subfield of F. Therefore, this P is the example of a prime field. Therefore, P in 1 is the example of a prime field. Is the example of prime field. We have a second example, ZP, where P is prime. Okay. We have second example, ZP P prime of a prime field, because we know that a group of prime order where ZP is the field of modulo P, field of integers modulo P. As we know that a group of prime order has no proper subgroup. As we know that a group of prime order has no proper subgroup, a field. This result also we know. Therefore, what we conclude that ZP has no proper subfield. अगर इसकी proper subfield होगी तो फिर वो क्या बन जाएगी, उसका proper subgroup बन जाएगी ZP का. तो proper subgroup बनेगी तो वो prime order है इसका, तो इसका कोई proper subgroup नहीं है. Therefore, ZP has no proper subfield. ZP has no proper subfield. Hence, ZP is also an example of a prime ideal. So we have two prime ideals. One is intersection of Fi's, where Fi subfields of F. Second example जो हमने दिया है ZP, where P is prime. This is also a prime ideal. Next, एक और एग्जांपल हम करेंगे. Q, the set of rational numbers. This is also a prime field. Example number third. Q, the set of rational numbers. Set of rational numbers. This is also a prime field. इसको हम प्रूव करेंगे. Let X be the subfield of Q. Let X be the subfield of Q. And we also know that a subfield contains at least two elements, namely 0 and 1. Therefore, 0 and 1 belongs to X because subfield contains at least two elements, 0 and 1. Therefore, 1 belongs to X. And M is equal to 1 plus 1 plus 1 is equal to M times. This is also belongs to X because we can write M multiplied by 1. This is the closure property of addition of X because 1 plus 1 belongs to X. That is why M belongs to X. Same way N belongs to X. Where M and N are integers. Where M and N are integers. We take let M over N belongs to Q. First of all, we want to prove Q be prime field. ठीक है. Let X be the subfield of X. Let X be the subfield of Q. This implies X is contained in Q. Now let M over N, irrational number, belongs to Q, where M and belongs to integers n not 0, and GCD of M and is 1. Now from this discussion we have proved that Mn belongs to X and N is non-zero, and because X is a subfield, therefore Mn inverse belongs to X implies M over N belongs to X. What we conclude from here that Q is contained in X. Q is contained in X. From first and second we prove that X is equal to Q. From here हमने क्या देखा कि कोई भी प्रॉपर सबफील्ड Q में कंटेन्ड नहीं है, therefore Q is a prime field. Thank you.